Okay, so you must be done with your structural diagram now, and hopefully you will come up with something a bit similar to mine. That's my structural diagram. It's not a fantastic piece of art, but you know, just to highlight, the idea is not to come up with something that you spend hours drawing. The idea is to really identify the main topographical, geological feature to get a sense of what is the structure of the area, and also to think about, okay, along my line of section, what is it that I'm going to meet? So let's start with the topography. So I've drawn the Colorado River here, the Bright Angel Canyon here with the river here. Coconico is there. You put a scale, an orientation. And in terms of topography, well, what we can see is there is a lot of relief. The river is, so you look at the scale, we're talking about 3 miles here. So the scale is 148,000. So 1 centimeter on the map is 480 meters in the field. And so we have that covers around 10 kilometers. And in terms of relief, the curves are in feet. It's quite good to notice that the curves are in feet. And we go from a bit more than 3,500 feet at the bottom of the gorge, that's a bit more than 1,000 meters, to more than 8,000 feet on the plateau, so that's around 2,400 meters here. So we've got nearly 1.5 kilometers of relief over this small area. Well, it's the Grand Canyon. There is active river incision. In terms of structures, there are a few things that are obvious. We've got faults that are obvious here with different orientation, different generations of faults. We've got this one which are northwest, southeast here, and we've got this one which are northeast, southwest that seem to cut across the other, so seem to have happened later. They seem to have a big impact on the morphology of the area. As you can see, the Bright Angel Canyon tends to follow that fault here. In terms of the different units that we can see in this landscape, I hope that, like me, you've seen two major unconformities. And I've represented them here. So we've got the red one here, and we've got the green one that I've drawn here on this diagram. So what are these unconformities? So the first one is at the bottom, and they are actually indicated on the map. You can see that the first one is at the bottom of the Tapit sandstone, and it's indicated as the Grand Canyon Revolution and Grand Canyon Peneplain. So that represents a phase of no sedimentation and erosion. So it starts in the sandstone, and we can see that we've got above the sandstone, we've got essentially a sedimentary succession from the Cambrian to the Permian, which is made of sandstone, shale, and limestone. In terms of orientation of the beds, we can see that the beds in this of this succession tend to be nearly horizontal, and you can see that by seeing that the contacts between the different beds follow very well the topographic contour. So the beds are nearly horizontal for that succession, and you can see there are a few places where you have deep direction, actually, like here, and the deep angle, and you can see the angles are 1.5 degrees. So very, very flat topography. It's not completely flat. There is here some monocline that are indicated that show a sort of kink in the beds here, but otherwise it's mostly horizontally bedded succession from the Cambrian to the Permian. Then we've got that unconformity that is at the bottom of the Tapit sandstone, and under that we can see another formation, and we can see that the unconformity is shown by triple points. We can see these triple points here. The bottom of the Tapit sandstone intersect many other contacts. So under the Tapit sandstone, we've got this upper Precambrian succession, which is made of dogs, sandstone, shales, limestone again, so it's sedimentary as well. In terms of bedding, well, you can see that it's, again, like the contacts between the different units tend to be quite contorted, tend to follow the topography, so it's, again, not very steeply bedded, but more steeply than the succession above, which makes that you end up with unconformity. The Rama formation is a seal that has intruded here within the Docks Formation in that case. Sorry, it's the Hakatai Shale here in that case. So we've got that succession bedded here, nearly horizontal again, slightly dipping. And then underneath that, we've got another unconformity, the Arizonan Revolution and Arizonan Plain. So again, another phase of no erosion, no deposition and erosion. And under that, we've got a metamorphic basement, a heavily deformed metamorphic basement, and igneous intrusion like the Zoroaster granite here. And you can see that when you look at the structure of this basement, what you can see, you have the foliation here, the dip of the foliation is indicated, and it tends to be everywhere very, very steep, like typically in excess of 70 degrees. And it can be up to vertical in places. And you can see that, again, all the orientation tend to be northeast, southwest, which seems to suggest at that time an equivalent compression northeast, southwest, very intense compression that led to the verticalization of the development of this nearly vertical foliation. The Zoroaster granite is here, intruded into these rocks, and this basement is visible at the bottom of the canyon, at the bottom of the canyons here. Okay. Now, a couple of questions about, there's not much folding visible in the area other than the folding of this metamorphic basement. And obviously it has to be heavily folded. And now I'd like to highlight a couple of questions. The first one is the unconformity. We said the first one is the bottom of the Tapit sandstone. Now, if that were true, like you would expect the Tapit sandstone to be deposited all across the area. Now, if you look in some places, it looks like the Tapit sandstone is missing. So you're going to pause now and try to think about how come that in places the Tapit sandstone is missing at the bottom of the unconformity. Think about the way they get deposited and where they are missing, and then we can come up with an answer in a minute.